the most precious resource. Tropospheric water vapor comes from evaporation over the oceans and plant transpiration. We also lose enormous amounts of water stored in lakes and dams through evaporation and runoff. If only this could be prevented. But evaporation is an essential part of the water cycle. Let us see how evaporation takes place. Zach noticed that the water on a wet floor dries fast than the water in a drinking glass. He already knows the boiling point of water is 100 degrees Celsius. Water vapor comes out when it reaches the boiling point. However, the remaining water on mopping the floor evaporates even at room temperature. We know liquid becomes vapor on boiling. Has the water on the wet floor reached the boiling point? To answer these questions, we must understand the difference between boiling and evaporation. The process of liquid changing into vapor below its boiling point is called evaporation. Evaporation can occur at any temperature, but boiling takes place only at certain temperature called boiling point. Boiling occurs throughout the liquid. Evaporation occurs only at the surface of the liquid. Bubbling is noticed during boiling, whereas there is no bubbling during evaporation. We come across evaporation in our everyday life. Drying clothes in the sun is a good example of evaporation at work. Similarly, as soon as you apply body spray, it disappears. Even perspiration evaporates after some time. Streets that are wet after rain eventually dry out as the sun shines. Spilled gasoline or petrol evaporates rapidly into the air. Even water from the surface of the sea evaporates, thus helping the formation of rain. Evaporation is a surface phenomenon. The wider the surface area, the greater the rate of evaporation will be. That is why a cloth spread on a rope dries faster than the one not spread out. Water in a glass doesn't dry quickly, because the exposed surface area is relatively small. When the temperature increases, the kinetic energy of the particles also increases. So, after an increase in temperature, the loosely held surface particles escape very quickly into the air. Hence, clothes dry faster in summer than in winter. That is why we struggle to dry clothes on humid days and in coastal regions. When the wind speed is higher, the surface particles move away with the wind, meaning quick evaporation. When we mop the floor, we switch on the ceiling fan to dry the floor quickly. To remove nail polish, we use acetone or any other nail polish remover. Nail polish remover leaves a cooling effect as it evaporates. Because when you apply any evaporating liquid, it takes away heat energy from your body. Let us do an activity to help us understand this. Take a 250 ml beaker and fill it with acetone. After a little time, touch the beaker. Absorption of energy makes the surroundings cool. The particles of the liquid, the heat absorbed to convert liquid into vapor is called latent heat of vaporization. The value of latent heat of vaporization for water is 540 calories per gram. You can easily catch cold if you are wet. Perspiration is the cooling mechanism of our body. The heat is absorbed from the body, leaving it cool. Cotton, a good water absorber, absorbs sweat and exposes it to the atmosphere for easy evaporation. On a hot, sunny day, people sprinkle water outside their houses or on their roofs to keep their houses cool. A glass containing ice-cold water has water droplets on its outer surface. When water vapor present in the air comes into contact with the ice-cold glass, it condenses as droplets. This condensation is a reverse effect of evaporation. Let's do a quick recap.